Friends, welcome to my YouTube channel. In this video lecture, we are going to solve all the questions from CRP5 chapter in Keith Williams' General Navigation book, the very first chapter. This chapter deals with CX3 based sums, simple formula based questions, very scoring, and these questions will definitely get asked in your exam. So let's start with today's question number 1, which is this. Now we have done this type of question many times in my previous video lectures. We'll do this again. What is the estimated time of arrival at Zulu if true airspeed is 120 knots, departure time is 1232, estimated time of arrival at Y is this 1247, actual time of arrival is 1250. So now we know the distance between X and Y. We know the departure time. We know the actual arrival time. With distance and time known, we can find ground speed. With that ground speed, we will find the time taken to go from Y to Zulu because we know the distance between them. Okay. So step number 1 will be distance between X and Y is equal to 42 nautical miles, right? Time between X and Y is equal to 1250 minus 1232. Light time 1250 minus 1232, that is 18 minutes. So now ground speed will be distance divided by time, 42 divided by 18 multiplied by 60. Convert 18 minutes into corresponding hours. So 42 into 60 divided by 18 is 140 knots. Next, step number 2. Your ground speed is 140. Distance between Y and Zulu is 70. So time between them will be equal to distance divided by speed. 170, 70 divided by 140. 70 divided by 140 is half, or 0.5 hours, right? So the time taken to go from Y to Z is total of 30 minutes or half an hour. Now you are leaving Y at 1250. So you will reach Zulu 30 minutes after 1250. So 30 minutes plus 12 or 50 minutes is 13 hours 20 minutes. So correct answer is option C. Next. Given the following conditions, true track is there, variation is there, drift is there. What is the magnetic heading required to maintain the given track? Now you have so true track is 192 and drift is 5 degree left. Now with a port drift, heading of your track is more than your track. So if drift is 5 degree port, so your heading will be more than your true track of 192. So your true heading will be more than 192 by 5 degrees. So it will be 192 plus 5, 197. 197. Okay. So that means your heading true is 197. Variation given to you is 7 degree east. With 7 degree east variation, your magnetic heading will be 197 minus 7 190 190 because variation is magnetic is least, therefore subtract it. So option A. Next question number 3. Magnetic heading is given to you, variation is given to you, drift is given to you. What is true track? Similar to previous question. So with a drift, with a starboard drift now. So when drift is starboard, your heading is less than your track. Now here drift is 4 degree. Heading of aircraft is 060. So track will be how much? So track will be equal to 060 plus 4, 064. Okay, so magnetic track will be more than magnetic heading, 064. So, so track magnetic is 064, variation is 8 west. So track, true track will be, now variation west, magnetic will be best. Magnetic will be more than true. So true will be less than magnetic by 8 degree. So 064 minus 8, 056. Delta is the correct answer. Next question 4. Aircraft is following a true track, true airspeed. Winds are given. What is ground speed and drift angle? So, okay, let's insert the values. True airspeed is 210 knots. True track is 48. Winds are 350 at 30. So 350 at 30. So ground speed is 192.56, approximately 192 knots, and true heading is 41. So ground speed is 192 knots, true heading is 041. The track given in the question is 048. Now as you can see, track is more than heading. 48 is more than 41, so track is more than heading. Now when track is more than heading, you are getting a starboard drift. A starboard drift of how much? 48 minus 41 is 7 degree. So correct option is 192 knots, 7 degree right drift. Okay, next. Flight level is given to you, Mach number, temperature, calculate true airspeed and local speed of sound. Now local speed of sound equals to 39.17, 39.17 temperature in Kelvin, absolute root of absolute temperature. Now outside air temperature here is minus 55 degrees Celsius, right? Flight level 350 or 35,000 feet. Now ISA temperature at this level should be 15 degrees Celsius minus 2 into 35. So 15 minus 70, that is minus, correction, 15, 55 degrees Celsius. Now convert this minus 55 degrees Celsius into Kelvin. So minus 55 plus 273 is 218 Kelvin. Okay, so 39.17 square root of 213. So 39.17 into root of 13 is 14. So into 39.17, 571.6, approximately 572 knots. That is your local speed of sound. Now true airspeed is equal to your Mach number multiplied by your local speed of sound. Mach number given in the question is 0.8. Local speed of sound is approximately 572. Now 0.8 into 572 is 457 knots. So you have to select that options which contains the closest values, closest to 572 knot and to 457 knots. Next, question number 6. There is a track given to you, any track. Wind component on that track you are experiencing is a tailwind of 45 knots. Plus 45 means a tailwind. Plus stands for tailwind, minus stands for headwind. Drift angle is 15° left. True airspeed is 246 knots. What is the wind component on the reverse track? Now this is a tailwind of 45 knots. Okay. We will find wind velocity. We will find wind velocity using CX3. Tailwind is 45 knots. True airspeed is 246 knots. So your ground speed will be equal to true airspeed plus tailwind, that is 246 plus 45, 91, 291 knots. Okay, that is your ground speed. Consider track 090. So you are flying on a track of 090, and you are getting a drift 15° left. Drift is 15° left. Okay, drift is 15° left. So your heading will be 15° left drift. Your track is going to be less than your heading. Now we have considered that aircraft is flying on a track of 090, right? Track 090. But since we are getting drift 15° left drift, the heading of the track will be more than heading of this aircraft will be more than its track. Track is 090, so heading will be equal to more than track by 15 degrees, so 105 degrees. So heading of this aircraft will actually be 105 degrees, so somewhat like this. Okay, 105 degrees, heading 105. Now using these values, we will find wind velocity on this track using CX3. So true airspeed is 246, ground speed is 291. So 291, 246, track is 90, true heading is 105. So winds are 220 at 83 knots. 220, wind velocity is 20 at 83. 220 at 83 knots. Next up, now true airspeed is again the same thing. True airspeed is 240 knots, 246, right? Course or track is 270 opposite, right? So this is the opposite track. Heading of the aircraft will be what? Heading of this aircraft will be on opposite track. Now while when going on a track of 090, the drift was 15 degrees. Drift was 15° left. Now on the opposite track, the same drift will become 15 degrees right. 15 degree right. So heading in this case will be equal to 270 minus 15, 255. So write your heading 255. Now substitute the values, this values in CH3 and find out ground speed. When you find out ground speed, you will come to know whether you are getting a headwind, a tailwind, and the amount of that, value of that. So 220 at 83 is fine. True heading 255, force 270, task 246. So ground speed is 184 knots. Ground speed is 184 knots. Now what is task? Task is 246. Ground speed is 184. So the difference between them is your headwind. So that means aircraft is getting a headwind of 246 minus 184, that is 62 knots. So the correct answer is minus 62 or any other option which is closest to this value. Next, question 7. Magnetic heading is given to you, variation is there, ground speed is there, wind velocity is there, what is drift? Now, magnetic heading is given to you. But look at the winds. Winds are reported in true. So convert this to winds, true winds in magnetic winds and substitute that winds in your CH3 to find out drift angle. So 235 is true. The variation is 40 degree west. True direction is 235. So magnetic will be how much? Variation west, magnetic is best. So 235 plus 40 is 275. So you will write in the CH3 winds coming from 275 degree at 120 knots. So magnetic heading is 255. Winds 275 at 120. TAS is not there. Ground speed is 375. So automatically you get a wind correction angle of minus 5 degrees. You get a wind correction angle of minus. True course is 255. True heading is 260. Okay. So course is less than heading. So true course 255. Heading is 260. Now when heading is more than course, what kind of drift is that? That is a port drift. This is a port drift of how many? 5 degrees. 260 minus 255 is 5 degrees. So you are getting a port drift of, or drift angle is 5 degree to the left or 5 degree port. Question 8. True heading is there. Task winds are there. Calculate ground speed. So heading 180, task 500. Winds are 225 at 100. So ground speed is 435 knots. Ground speed is 435 knots. Task 500, heading 180, 100 knots, 225, 435 knots ground speed, course is 171. Next, question number 9. True heading is given to you. True airspeed, ground speed, drift is given. What is wind velocity? Now with the help of true heading and drift, you can find true course. Now drift is 7 degree right. So with a starboard drift, your heading is less than track. Now starboard drift is 7 degree. Heading is 310. Track will be how much? So track will be equal to 310 plus 7, that is 317. Now substitute these values. At 317, heading 310, TAS 200 knots, ground speed 176. TAS 200, ground speed 176. So you get a wind velocity of 270 at 33 knots. 270 at 33 knots. Option brown. Question 10. Through heading task ground speed drift given to you, calculate wind velocity. Same thing. With a starboard drift, your heading will be less than track. So starboard drift of 5 degree, heading 90 degree. Your track will be how much? Track will be 090 plus 5, 095 degrees. Okay, track will be 095 degrees. Substitute the values here. Track 95, TAS 180, ground speed 180, through heading 090, wind speed 15 knots, wind direction 2 degrees. Let me check the question. Through heading 90, TAS 180, ground 5 degree. Okay, so wind velocity will be 2 degree, approximately 360 at 15.7. 15.7 knots. So the correct option will be option A, 360 at 15 knots. Okay. So wind velocity is 002 degree at 15 knots. Okay. Closest option is 360. So we'll stop here. We will do the next 10 questions in my next video lecture. Till then, practice these questions. Let me know your doubts, comments in the comment box. Do subscribe to this channel and share this video with all your friends. Don't forget to like this lecture by hitting the like button. I thank you for your time and I'll see you in the next video.